Magandang araw. Ako si Kuya Code. Welcome back to my channel where I discuss Python programming challenges. Today we'll continue with the Python set problem. So I'm going to be going over these five here: symmetric difference, union, intersection, difference, and then a different symmetric difference operation. So firstly, I'm going to open up my IDE here, and I'm just going to make two sets. So first is set A. Let's just do 1, 2, 3, and then we'll do set B equals 3, 4, 5. So now we have two different sets. So these methods are very good. It's important to know for more advanced topics like data science and math specific topics. So the first one I'm going to go over is union. So let's just make another variable called union set A. Actually, rather than doing set A, I'll just make it easier and just do A and B. So A dot union, there's a method called union, and we can just pass in B, and then we'll actually print it out, and then you'll see what's happening, and then we can explain it. So union, union set. So as you can see, set A is 1, 2, 3, set B is 3, 4, 5. But union in this context means basically you're combining both of the sets together into a new set. Of course, because it's a set, it's not going to include the second 3 because sets, all the values in a set are unique. So it just removes one of the 3's because you only need one. So simply enough, union combines two sets into a single set. There is an alternate way. So for all of these, you can do it with the actual method. Where you can call the method on one set and then pass in a second set. And then in some cases, depending on which one you call the method on, the result would be different. But the other way is actually union set equals A bar B. So if I do that, actually what I'll do is just do like this. So if you print that, it ends up being the same. So the bar is basically, it adds the two sets together and of course removes any duplicates like usual. So that is union. The next one is also pretty simple. I mean, most of these are pretty simple, if not all of them. The next one is called intersection. So we can just do something similar. We'll get set A and we'll call intersection. And we'll just pass in set B. I'm going to comment these so they don't get printed. So this one only gives you the values that are in both. So 3 is the only value that's in A and in B. So that's the only one that's printed. And just like with the previous example, we can just still do print. And then for intersection, it would be the ampersand. So A ampersand B. So that, of course, is going to be the same thing. So this is for the intersection. Next, we have different. This one is a little bit different in depending on how you organize these. So, or how you have this printed out. So we'll just do our first print statement. So first we'll do A difference B, and we can actually also do B difference A. Because of course in this case, it doesn't matter which one you do, you're adding both sets together or combining both sets, it's going to be the same. Same thing with this one, it doesn't matter which one you do. But with this one, it should give us a different result. So this is basically kind of the opposite of intersection. So for the first one, take set A and only give me the values that are not in set B. So because the set A and set B shares a 3, 1 and 2 from set A are not in set B, but if you do the opposite, 4 and 5 are numbers in set B that are not in set A. So it's kind of basically the opposite of this one. And then simply with the other way, it's simply just A minus B. And then of course, you can even do B minus A. So that'll give us the same result. Yep, that gave us the same result. Okay, so that one's done for that one. Next is the symmetric difference. So for that one, we can just do, of course, A dot metric difference. We'll pass in B. And then let's see if this gives us a different result if we do it this way. B, symmetric difference, A. Oops, let me just close this and do it like that. So did I do something wrong for this? Oh, I did the same thing twice. So it looks like it did give us the same one. So what this does is it returns elements that are in either set A or set B, but not in both. So it basically takes this and adds this. So of course you have 1 and 2 are only in A, but not B at all. And then the 4 and 5 are only in B, but not in A. And it doesn't include 3 because 3 is in both, so that one doesn't count. Alternatively, you can just do use the caret operator, which is shift 6, which is print A, caret operator B. These two are the same, so we technically don't even need that, but you get the same result. So if you do this, as you see, it's the same thing. Of course, you would be able to do it like this as well, where because technically symmetric difference is a union of this and that, you could literally just do this. Take that one, you take this one, you do the union operator, and that would also do the exact same thing. So this is the same way as doing it like that. But of course, this way is easier, and easiest is using just the caret operator. So those are the ones that we have for this video. Now, of course, we're going to the Hackerrank problems. Let me double check one thing. One thing that's kind of weird about this website is the code you type in is saved based off of cookies. So if I have another account and I have the answer and I go to this account, even if it's not completed yet, it'll still show it. So let me just double check quickly. So symmetric difference. I'm pretty sure these are very similar, very simple problems in general. Okay, it looks like we're good. And also in these, the good thing about these is that it does show a useful diagram. We'll just start with the union one here first. So for union, as you can see, if A is a set A and B is set B, when you union them, when you have the union operator, basically the entire area is highlighted because it includes both of everything. So let's see here. This is just examples of what we've kind of already discussed. So we're given a number, which is how many numbers we have, and then a second number, which is also how many numbers we have. These are arrays. So we'll have to do n equals input. Let me just see here. Input. So there's that, which is the 9. And now we need another one, which is set A, which would be input dot split. So I believe this would be set A. Taking all these numbers, you're splitting them, and then we are doing. Oh yeah, we have to do the map. So make that into a set. Inside the set, we'll have to map through it, and then for the function, or in this case, it would just be convert them all into ints. I've mentioned this, many times in other videos. So we'll do the same thing for the other one. We could just, this is m, which is the second number here, and then copy this down, set b for this one, and then, like I mentioned, let me close that. All we have to do is really take set A and take set B, and then just print out the union. Except, let's see what the parameters are here. roll number of students who have at least one subscription. Roll numbers 1, 2, 3, 4, 1, 2, 3, 6, and 8 are in both sets, so they only counted once. The total number is 13. Let me just double check. The student of District College have subscriptions to English and French newspapers. Some students have subscribed to only English. Some have subscribed to only French. Some have subscribed to both. You're given 2 sets of roll numbers, which is what we have. One set has subscribed to the English newspaper, and the other set is subscribed to the French newspaper. The same students could be in both sets. Your task is to find the total number of students who have subscribed to at least one newspaper. So let's just see here. We'll print out. We need the total number of students, so we can actually just use length to count the ending result, and you just literally take set of A union B. So we'll just combine them, and it'll remove all the duplicates. And then the length of this set, these are all the unique ones, and then we just find how many unique ones there are, and that should give us our answer. All right, so that's 13, perfect, and we'll go ahead and submit that. All right, so that's the first one done. I'm going to copy this because I'm pretty sure that the other ones are very similar. So that was union. We'll go back to easy, unsolved, and now we'll just do the intersection, which is a number that exists in both of them. So as you can see in the diagram, you have set A, you have set B. Only the green part is a section that exists in both of these. So let me just check. The format is the exact same, but now you only have to print out the roll numbers of students who have both subscriptions. So literally we can just do the same thing we had before, but instead of printing out a union of those, we can just print out the intersection, which uses this operator. So go ahead and we'll try that. We should get 5 for our answer. Yep, and we got 5. Go ahead and submit this. All right, congratulations. We'll go to the next one. I guess I could have clicked next challenge, but I just wanted to make sure it goes to the one that I'm specifically wanting to go to next, which is the difference. Click on difference. And for difference, it's the green is highlighted because it's excluding all of B, and it's excluding the ones that are in both. Let me see here. Yeah, output the total number of students who subscribe to only English. So if set A is all the English, set B is all the French, and then this middle section is both of them, we can just literally do A minus B. And actually, we'll check just to show you if we did the opposite. If we do B minus A, maybe that just gives us the same value just by pure coincidence. But as I showed in my other example, in this case, the results were different because one of them gave us 1, 2, the other one gave us 4, 5. But like I said, you're taking all the ones that are in English and you're removing the ones that also have French, and that would give us the ones that are just English. We'll go ahead and submit that. And the next one is, I guess that was already difference. We'll have to do some metric difference next. Let me just see if this one goes to the one that we're looking for. Okay, this is the one that we're looking for. So yeah, the code is the same. Symmetric difference, that would give us we'll have to do the caret operator for that. Let's just read this. The symmetric difference operator returns a set with all the elements that are in set A and iterable, but not both. So yeah, sometimes use the caret operator in place of symmetric difference method. So this should give us 8 if we just use the caret operator. So like I said, it's taking the, let me just read my, Yeah, it returns the elements that are in either set A or set B, but not both. So that are unique to set A and unique to set B, but not that are in, but not both. So yeah, that did give us 8. Okay, and then I think there's one more which is basically the same as this one. Did I? I think I already did. Okay. See, this is symmetric difference operation, and then there's another one just called symmetric difference, which is, I think the problem is slightly different, but the input is the exact same. Yeah, this input is the same. So we can still do it like that. And let's just read the problem here. The first line is all the m. Yeah, the second line is the m number of integers, which is right here. The third line is n, and then the fourth line is the n number of integers. Given two sets of integers, m and n, print their symmetric difference in ascending order. The term symmetric difference indicates that those values that exist in either m or n, but not both. We have to print it in order. So normally we would have just done, you know, A caret operator, B, which I guess we could still use the same thing, but now we just have to have it printed. So there's actually a method called sorted, and then we just do, I think we should just be able to do A caret B. I think that should give us, because then it would sort those. Oh, it's because this is a list, and what we're looking for is the individual numbers on a different line. So what we'll do is we'll save this as a variable or a list instead, and then we can simply iterate through the list. So for I in C, we'll just print I, and that way each value will be printed on a new line. So that should give us what we're looking for with this one. Yep, that does give us what we're looking for. Go ahead and submit. That's really chugging. Hey, look, we got it. All right, so that's it for this video. Let me just check here. There's not too many set ones that are left. Mutations, Captain's Room. These are specific problems where you take the operators that we used, plus all the past stuff, and then these are like special challenges that we have to try to solve. So those will be some good videos for next time. So if you found this helpful, please like and subscribe for more coding challenges. Let me know in the comments if you have any questions or suggestions for future videos. See you next time on Kuya Code. Paalam.